All right, in the previous sections, we created one simple moment and we also created a circuit based on the moment. In this section, we are gonna learn a little bit more on how to create series of moments and circuits. Circ supports append method to create a circuit.append. That is the command, that is the syntax, circuit.append. You can append moments to circuits or append one or multiple circuits to another circuit. So it's a very flexible way of appending either a moment to a circuit or a circuit to a moment. Sorry, circuit to another circuit. At the end, you are appending it to a circuit. I repeat it one more time. You can append a moment to a circuit as well as another circuit to a bigger circuit. So let's look at it. So this is the first moment, very simple. We are creating a grid qubit here as done in the previous sections. We define two gates, H and X, operating on qubit 0 and qubit 1. We created our first moment with H and X gates. We defined circuit over here with moment 1. It's very similar to what we have done earlier. Now what we are going to do is append another moment. Please note that in this particular example here, I am not defining a moment per se. Here I defined a moment, appended it, created a circuit out of the moment. Now I'll have to append it. Please note that you don't have to necessarily create a moment always. You can just write the gates inside the circuit. So here I'm creating a moment on the fly. So circuit, which is this one, dot append circ dot h and circ dot cz on these gates. So created a moment here. Let's look at it. This is the first moment. That means you created H and X gates using 0, 0 and 0, 1, 1, 0. And then you append this moment. So look at this. Spend some time. Feel free to pause the video. So in the first one, you had H and X. You have H and X. In the second one, you have, this is a moment. A moment goes in this direction, vertical. In the second moment, you have H, then you have CZ gates, G1, QG1 and QG2. So you have G1, G2. You have this gate is known as CZ gate. And that's how you appended the first moment with the second moment. Please pause the video and let's do a hands-on. In the previous section, we saw how to create a series of moments and circuits. Again, using the same notebook, we will do another append. Again, following the same example as in the previous section, circ.moment, gh and gx. Please see in this previous section, we used moment 1 and we created a moment on the fly. Now, what we want to do is add one more moment to it, append another moment. So this was the first circuit and this is another moment which we are going to add it over here. Again, you would do circuit.append circ.h qg2 circ.cz q0, the same thing. So this was the output of this one and I appended the second moment. This is moment 1, moment 2, moment 3. This is the first moment, this is the second moment, and this is the third moment. So slowly and slowly we built a circuit out of moment. Let's do this hands-on. Now, there is another method to create a circuit. You can create a circuit by just adding the gates to a circuit without creating any moments. Again, please look at this DIY. So circuit 3 equals circ.circuit and just go on adding. You can just write the gates and you don't have to create moment explicitly. So this is how you can create a gate. So I can explain CZ, QZ0, QG1 here, C circ GH, QG0, H, then QG1H. Please note that as to these two are different and they are applied at different qubits, always it gets to the left aligned. So I repeat, the first one operates on 0 and 1 on these ones. So they are together. In the next moment, please note that H are applied. The gate H is applied on two qubits, 0 and 1. So they form a moment. Then circ.x on 1 and then 1 and 2 here. So please, we will see in the next section what these moments mean and how do you arrange moments and circuits together. But always remember that by default, they are left aligned to the left. Let's see the hands-on on this one. Let's do this hands-on. Quantum DIY number 4, additional moments and circuits. The circuit.append method.ipynb. The notebook is available in the Google Drive link mentioned in the video description section below. So as done in the previous, import circ, and then here we use the grid qubit I and 0 for range 3. So this is always going to be 0 and 3 would be I will change to like vary from 0, 1, 2. And you have two gates, H and X defined, G of H and Gx, G underscore H and G underscore X. We create the moment as in the previous hands-on exercise. Then we have circuit.circ equals circ.circuit moment 1. We create the first moment and we appended the moment here as well. Next, we create another moment and append to this circuit. Let's do that. Here we use circuit.append circ H QG2 and circ.cz Q underscore G0 Q underscore G1. Second moment, and note that circuit.append is the function used. And finally, this is another circuit which is being created over here. Print circuit 2. I'm creating another circuit. Circuit 2 equals circ.circuit. Moment 2 equals circ.moment. And I appended this moment 2 to this circuit 2. Next, I am going to append the circuit 2 to another circuit, which is the circuit we created in this section. So doing it again, you see the original circuit, which is here. This was our original circuit from the previous section. Next, I'm creating another moment with a new circuit, circuit 2. So I'm going to print the circuit 2. There is only X in this circuit. And now I'm appending circuit 2 dot append the circuit 1. That means first the circuit 2 is going to appear, followed by the circuit. So circuit 2X is here, and then you have H and X, HX, H, C gate, C gate, H, H, C gate, C gate, H. So you see how these circuits and moments can be appended and formed a circuit. In the next few sections, we are going to discuss how these circuits can be manipulated, modified, and then we will simulate the circuits and run the circuits to do something known as measurement, which is in the following sections. So make sure you do hands-on. If you don't understand, pause the video, put some questions in the comment section, and again, happy learning.